Alright guys, so this is the video for section 8.1, and this chapter is sequences and series. So some of this, if not all of it, will probably be very new to you, and it may be something you've never seen before, so you may get a little uncomfortable from time to time, but push through and you'll get it. But before we start, I just want to talk about what a sequence is, okay? And just like, you know, when we use sequence in the English language, it's just a pattern, okay? One after another after another. And that's a lot of what we're going to be doing in this chapter is looking for patterns, okay? And sequences can be either finite or infinite, okay? So they can be finite, that means they start at a number and then they stop at a number, or they can be infinite, which means it goes on forever and ever and ever and ever, okay? So each of these numbers in the sequence is called a term. Okay, so you'll hear me talk about terms a lot. Anyways, let's go ahead and there's two different kinds of sequences we will be talking about. One is arithmetic, and that's when we add the same number to each one. And then the other is a geometric, and that's when we multiply by the same number for each additional term. Now, there are many sequences that are neither arithmetic or geometric, and we're going to see them a lot, but those are the main ones that we're going to kind of title and kind of go a little bit deeper into. All right, so with that said, let's look at example 1. Okay, so example 1, it just says write the first 3 terms. So if this is a sub n, we would write term 1 as a sub 1, we would write term 2 as a sub 2, and term 3 is a sub 3. Okay, and all we're going to do is a sub 1 would be when we plug 1 in for n. So it's just 2 times 1 plus 5. Then a sub 2 would be 2 times 2 plus 5. And a sub 3 would be 2 times 3 plus 5. Okay, now if we simplify these, we would get 7, 9, and 11. Okay, so as you can see, this one we add 2, and we'll discuss this a little bit later, but this one we would call an arithmetic sequence because we're just adding the same, you know, we're adding 2 for every next term. Okay, so let's look at part B now, okay, and some of these look differently. So rather than having a and n, it's just f of n, so we would just find f of 1, we would find f of 2, and we would find f of 3. Okay, and what that means is we just plug 1, 2, and 3 in for n, so this is negative 3 to the 1 minus 1, this is negative 3 to the 2 minus 1, and negative 3 to the 3 minus 1. Okay, so this is negative 3 to the 0 power, and anything to the 0 power is just a 1. This is negative 3 to the 2 minus 1, so negative 3 to the first power, which is just negative 3. And this is negative 3 squared, which would be negative 3 times negative 3, which is a positive 9. So these would be the first 3 terms of this one. Okay, and as you can see here, we're multiplying by negative 3, we're multiplying by negative 3, and as we'll talk more later, this would be considered a geometric series. All right, so let's look at example 2. Okay, it says describe the pattern, write the next term, and then write a rule for the nth term of the sequence. Okay, so this is where we have to really rely on our number sense. Okay, so negative 1, negative 8, negative 27, negative 64. Okay, and some of these are pretty thought-provoking, so if it takes you a little bit, don't be alarmed, okay? So if this is just negative 1 to the 3rd power, this is negative 2 to the 3rd power, this is negative 3 to the 3rd power, and this is negative 4 to the 3rd power. Okay, so that's the pattern that I have here. So the next term would be negative 5 to the 3rd power, which is just negative 125. Okay, and then to write the rule, all we're doing is I'm saying, okay, well, with each term, this is a sub 1, this is a sub 2, a sub 3, a sub 4. So I could just write my next term as a sub n, so for any number, it's going to equal negative 5 to the, it's going to be negative n to the 3rd power. There we go. So this would be our rule. All right, so go ahead and pause this, Try to be on your own. This one's a little more difficult, so if you can't figure it out, don't get frustrated. But go ahead and pause this and try, and then we'll go over it. All right, so hopefully you've attempted this, okay? So what I like to do is this is my A sub 1, or my first term, my second term, my third term, and my fourth term. Okay, if I look at this, guys, this here is 0 times 1. Okay, this is 1 times 2. This is 2 times 3. And this is 3 times 4. Okay, so if I wanted to find my next term, it would be 4 times 5, which is 20. Okay, and if I want to find a rule, okay, I'd write A sub n equals. Now notice, this is my first term, second term, third term, fourth term, and that's always my bigger of the two numbers that I'm multiplying, right? So it'd be something times my n. Well, it always is the number in front of my n, so I could put n minus 1 here. Okay, so this would be my rule. Now, if I look at this, guys, we know my first order differences aren't the same. But if you look at this, you could tell that your second order differences are the same, which means this is going to be a quadratic function. Okay, and think of what a quadratic function means. That means we have something squared, right? So you should know that you're going to multiply two numbers to get that. All right, let's look at C now. Okay, so if I didn't, for now, I'm going to pretend like the negatives aren't there. Okay, so this is my first term, or my A sub n. This is my second term, third term, fourth term, and fifth term, right? And this is just, and like I said, I'm going to forget my negatives there for now. This is 1 over 4. This is 2 over 4 reduced. This is 3 over 4. This is 4 over 4. And this is 5 over 4. Okay, so if I wanted to find my next term, it would be 6 over 4, which is 3 halves. That would be my next term. Okay, and then if I wanted to find a rule, A sub n, and for now I'm going to forget about the negatives, okay? So I'm going to leave a little bit of space here. And this is just, notice, this is my first term, second term, third term. So I'm just going to put n over 4. Okay, now what makes this go negative, positive, negative, positive? Okay, well, if I multiply this by a negative 1, it'd be a negative. If I multiplied it by a 1, it'd be a positive. Okay, so in order to go negative, positive, negative, positive, we're going to multiply by a negative 1, and we're going to really pay attention to the power here. Okay, so the power of our first term is negative, so we want this number to be odd when we have our first term. So this is just negative 1 to the n. Okay, so think about it. Negative 1 to the first power is negative 1 times 1/4, which is negative 1/4. Okay, negative 1 to the second power, remember negative 1 times negative 1 is a positive 1, so that would mean this is positive. So that's how we get the alternating positive and negative, okay? And like I said, to figure out what the power has to be, think of if the first term is positive or negative. If it's negative, you want it to be n. If it's positive, you want like n plus 1 probably, or maybe n minus 1, depending on what your first term is. All right, so let's look at example 3. Okay, it says in a video game you start with 12 points and earn 2 more points for each minute that your avatar is active. Okay, so we start with 12, and for each additional minute we get 2 more points. Okay, I'm ready to roll for the number of points for each minute the avatar is active. All right, so I'm just going to say A sub n equals 2n plus 12, right? So if it's active for 1 minute, I would add 2. If it's active for 2 minutes, I'd add 4. 3 minutes, I'd add 6 to 12. Okay, now if I go to graph this, I start at 12, right? Okay, and when my n is 1, I go up 2. When my n is 2, I go up 4 or another 2. So it'd go like this. And notice this is a discrete function, guys. It's not continuous, so I would not connect the dots. Okay, think of like I don't get a half point for a half minute, or for a fourth of a minute, I guess here, okay? There's no halves, there's no fourths, nothing like that, okay? So I would not draw a line through those points because it is discrete. All right, so go ahead and if you want to do this monitoring progress, feel like you need the extra help, go ahead and pause this video and do it. I'll work it out, and then you can unpause it to see the solutions. All right, so this is what you should have gotten. All right, so anytime we're dealing with series, usually you can see a summation notation, okay? And it looks something like this or like this. Okay, now the summation notation is used with sigma, and this is sigma. Okay, and you have a few things that goes with sigma. So the equation out here, this is like what we've been calling our rule. Okay, and then usually you have I equals, or sometimes you'll have N equals or K equals or whatever. So it can be, like in this case, most of the time it's going to be I equals 1. That means we start at A sub 1, or we start at the first term. And then up top, you can see a number, so 5. That's where we would end. We would end at the 5th term, okay? And the sigma itself means we're going to sum all of our terms. Okay, we're going to add them all up. And some of these get really big, really, really fast. So if you get a really huge number, don't be alarmed, because that very well could happen. Okay, so this is for a finite series. So this one would be like the sum of 2i from I equals 1 to 4. So we do the first 4 terms of 2i, add them together. We can actually sum up infinite series too. And the only thing different on that is we would put an infinity at the top that just says we're going forever and ever and ever. And I know it seems really, really weird for you guys, especially those who like to try to understand things conceptually, but we can sum everything even up through infinity. All right, so if we want to write these in summation notation, okay, first we want to find our rule. Okay, so this is our first term, our second term, our third term. We don't know what this term is yet. Okay, so notice this is just 25 times 1. This is 25 times 2, 25 times 3. This would be 25 times 10. And notice there's not a dot, 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 which means it ends here. Okay, so this would be our 10th term. So if we wanted to sum all these, we'd write it in summation notation. So we'd write our sigma, okay, and would write our I equals, we're going from the first one to the 10th one, okay, and our rule would be 25i, okay, and that's all we have to do there. Okay, over here, okay, this is our first term, second, third, fourth. Notice there's no end in sight, so it goes towards infinity. Okay, so if I'm going to add them all up, I'm going to use my sigma, because that's what tells me I need to add them up, is my sigma. And I'm starting at the first term, and I'm going to infinity this time. Okay, and here notice it's just 1 over 2, 2 over 3, 3 over 4. So this number is the same as our term. So this would be I over. And this on bottom is just 1 more than our numerator. So I'm just going to put I plus